for cyanophenol, where you still have a phenol. If this is carbon number 1, then that's going to be carbon number 4. So same thing happens here, except a methyl. Now you have a nitrile, which is called a cyano in terms of a substituent. So both of these still act like acid because the phenolic hydrogen is it's more acidic, and they tend to lose that. So that both of them are still acids. So let's draw their conjugate bases to compare, so we can create the change and then evaluate. Okay, so that's there. Then here we have a nitrile. I'm going to blow up the picture of nitrile so we can see what's the connection between carbon and nitrogen. Alright, so now since you have a negative charge on oxygen, the carbon next to it is going to be partially positive, because oxygen is going to pull, it's more electronegative, so it's going to pull the electrons towards itself. So if this becomes partial positive, the carbon next to it becomes partial negative, because of the positive carbon there. So it goes all the way around the chain. So you will get partial negative charge there. Now carbon don't do anything, and carbons actually donate. Hydrogen connecting to carbons don't do anything. So you already have a negative charge here, but now this carbon is also going to donate towards this negative charge. So it's going to donate towards more negative charge. So it's localizing the negative charges. Now let's come up here and see what happens here. This is still negative, so that's partial positive, partial negative, partial positive, partial negative. Alright, now nitrogen is more electronegative than carbon, so it's going to pull the electrons towards itself. That means this will be partial negative, so carbon has to be partial positive. This partial positive and this partial negative stabilizes each other, so it makes the overall structure more stable than the 4-methylphenol. Because these hydrogens don't do anything, the carbon's still going to donate in, because there is no other atom that's taking away the density. So this is localizing the negative charge. This is delocalizing the negative charge. So when you delocalize, it's more stable. It makes it more stable conjugate base, and more stable conjugate base, weaker the conjugate base, stronger the acid. So the answer for this is 4-cyanophenol. This is a very classic type of problem where he can easily change what is attached there. You have to determine, you have to know actually what's the connectivity of those functional groups, and then how does it donate or withdraw based on the structure that's given. So always try to work it out this way when you have something attached onto phenol or any other functional group that could act either as an acid or as a base. Alright, I hope this helped.
The Teaching Center, UF's Learning Resource Center.